Okay,
Thank you very much.
Good morning, everybody.
Yes, we can see. Can you see our screen?
We can, yes.
Yes, perfect. Hi, everybody.
So I'm Meola. I work at CHUV since 4 years. I started as a quality manager in the oncology department, and now I'm a project manager for specialized for logistical flow.
My name is Nicolas Membrez. I'm project manager in ProcSim, which is a company which uses FlexSim every day. And here, this project we will show you is the model is done by Bertrand Ray, which is our simulation expert, and is not there because of holiday today. So we will try to answer our question as we can.
So regarding our presentation, so we will start by a short presentation of our company. Then we will explain the context of this project of the new children's hospital, as well as challenges and needs in terms of public elevators. Nicolas will present you the methodology used for this simulation and this analysis and result. And finally, we will give you, each of you, our conclusion and decision following this simulation. So the CHUV is located in Lausanne, is one of Switzerland's 5 university hospitals with Geneva, Bern, Basel, and Zurich. Is one of the 10 best hospitals in the world according to the Newsweek magazine. We employed 11,942 employees, include 107 nationalities represented and 69% of women. So on the left, we can see the K number of 2020.
So by my side, I work in ProcSim. We are based in Lausanne. We are a team of 12 engineers, and we are doing a lot of 3D simulation using FlexSim. And we have a department of AI and in optimization. So we are doing personal optimization algorithm. We are active in the healthcare, the industry, and the transport. So we help the different companies to take decisions about the flow. The collaboration with CHUV and ProcSim is a long-term collaboration. We had a lot of challenges, and just to explain, give a panel of projects. We did several projects with the simulation. It was about the first one was about the GV network for the logistic. We optimize some logistic flow between buildings. We modelized a pharmacy integrating a robot. We did the opening of a new operation rooms. A big logistic platform which they serve different hospitals, which name is Plexus. A project about emergency regarding to the reduce of the area of the emergency. So how will function the emergency flows. Last year was a big project about synchronize 2 operating theaters. It was about patient flow and logistics for these operation rooms. And this project we will show you in another new building today is the Children's Hospital.
Regarding this new project, so we started the construction in 2019, and the opening date of the new hospital is planned for April 2024. The current children hospital is located in Lausanne, in the middle of downtown, so it's difficult to get to, and it's an old building. The aim of this project is to centralize all pediatric care in a single building near to the CHUV. So, oh, sorry. Yeah. It will be several consultation and hospitalization area, an emergency department and operating rooms, and also classroom and play areas. During the first operational steering committee, the building department identified an issue regarding the availability of the public elevators. So as you can see on the plan, there is 2 public elevators and 5 beds elevators. So only 2 public elevators for 7 operational floors. So we decided to mandate ProcSim services, and the aim of this mandate is to optimize on vertical flow and to define an organization of all lifts for flow of people, patient, visitor, and employees. So lifts have not been assigned to this various flow, so there is a risk to have a longer waiting time for these both public elevators. And the issue with this simulation is that we are at the beginning of the project, so it was difficult to obtain some data regarding the flow because they are not characterized, and the occupancy rate of this future new hospital is not available. So meanwhile, the construction of this new building continue, and we had to give the results of the simulation as soon as possible. So in 1 month, it was a good challenge.
About our job, so the ProcSim mission and methodology. So first we have to understand the structure. As you can see in the picture, here the building is about 11 floors, 6 access or connection with other buildings that you can see in green on the picture, here, here, and here, and 69 origins and destinations for the flow, the staff, the flow of the staff, the visitors, or the patient. And we had to understand how this structure before the building is out of the earth. I don't know if in English that's right, but that's the idea. After we had to identify, quantify, and characterize the flow. It's about the volume of employees, the patient with accompanying persons, the visitors, and this volume we had to understand when they are arriving during the day, and the macro process. So it means that the step that shift the use of the elevator during the day. For example, an admission time. After, our job is to simulate user flow and behaviors. It means there is some human behavior that we have to approach. For example, the choice for elevator, bank, or stairs. If I go down, if I go up, etc. The behavior to select a bank according to the queue, depending on the queue at a given time. For example, if you have some people in the front of a bank, you will choose another one. Important thing that we are in children hospital, and the children are never alone. There is only a brother, a mother, or other accompanying persons. So we have to consider them. After this, the transport type, we have how do you say that, wheelchair, and these 2 these two parameters change the use of the elevator. After that, our job is to identify bottleneck and propose solution. So we have a total time, which is combined with elevator waiting time and elevator ride, and which KPI is relevant. So the experience inside the CHUV has shown that the waiting time in the cabin is more important for user than the other KPI, than the total time or the elevator ride time, despite the potential for global performance. So according to the customer, we use this KPI.
After the first estimate of ProcSim, which was not really good, the building department identified a location which there was the possibility to add new elevators. So in purple in the plan. This new elevator will located in front of the two existing public elevators. We decide to analyze 4 scenarios. The first one is the base, that is the initial situation with the two public elevators. This combined to with the use of stairs by the employees. The second is the addition of the third public elevator in the upper, as mentioned before. The third scenario is the opening of bed lifts on the consultation side only for employees. And the last one is to turn a bed lift into a public elevator on the consultation side.
About the analysis and the result, without going in detail, the first situation was only 2 public elevators, and you can see the staircase. And without going on the detail, we can see here the volume of the people who are using the elevator. And we can see there are 3 peaks in the morning, at the lunchtime, and in the evening. And the majority of these peaks are the employees. You can see here in green the person who are waiting less than 30 seconds, and in red the person who are waiting more than 2 minutes, which are the critical values. Duration of the waiting time. If we just take this KPI here, without stairs, the satisfaction rate is 49%, and if we use the hypothesis of the stairs, this ratio increased to 57%. It's better, but it's not enough. That's what we can conclude here for the hypothesis without and with stairs. So after we decide to analyze the scenario globally, and first you have here the satisfaction rate here in green, which is this one is the first scenario. The first conclusion is that adding a new elevator is necessary because it's not enough here, 57%, and there are 7% of critical value. After adding an elevator with upper configuration, improve result here, but it's not sufficient because 72% are satisfied, but there are they are again critical value. And after we try to allow staff member to use the bed elevator on the consultation side here in this scenario. It's the scenario 1 plus 2 plus allow the staff to use 2 bed lift. and the ratio here now is better, and critical value are very small. And we try this last scenario, and the idea is on the consultation side, we allow all the public to use only one elevator, and this scenario is not good because we have critical value, more critical value than the third, and it creates more waiting times, and the simulation can show us that. Yes. After another KPI, we can see here the waiting time in the on the desk side. This different scenario here, the rate here is good, and there is no critical value on this side of the desk, on this side, sorry. And on the consultation side, we can see that 73% are satisfied, and there is only 1% of the person who are waiting more than 2 minutes. And the last scenario here, we can see on this side, it's good, and on the consultant side, it's not good because we have a lot of critical value. After about the peaks that we saw before, in this third scenario, we can see there is no critical value in the peak that we identified before. And the last one show that there are critical value on the last scenario. Just to understand how many places or surface we need, we had to understand what is the size of the queues. So first we identify which floor is as the biggest queue. So here we can see that's the ground floor, and if we just analyze the ground floor through the 4 scenarios, we can see that during the week there is 1 point at 5 on the consultation side, and 11 one time at the desk side. And we also use the simulation to show the model to show to our customer which place what is really in terms of a visual the situation. And here we can see that the person 11%, it's not grave, it's okay, and there is place next to this area. So yeah, I will answer the question after, please. It's the first exercise for me. We'll do that after. And on the consultation side, we can see that the biggest queue is 5. So in this area, it's all okay. The question is after who is waiting and when. So here an important thing that is that we don't want that the patient wait. So if staff is waiting, it's okay, but not the patient. So here we can see the evolution of the different scenario and the critical value in for the waiting time. And so we can see first conclusion is that the patients are impacted by these waiting times. So the collaborator too, and we can see that adding an elevator in the upper as well, allowing the staff to use bed elevator in the consultation side, improve the result for all the time, for the patient and for the collaborators. And that the percentage of user waiting more than 30 seconds is halved. And the second point, allowing a public access to one elevator on a consultant side, create new waiting times for staff and patients. So that was the point. So here in this scenario for patient, there is we can say no critical values for the patient. In synthesis, on the ProcSim side, the initial situation without stairs is unsatisfactory. The Wister hypothesis is necessary, so the CHUV need to do something with the persons, with the staff. The initial situation with stairs is unsatisfactory. An additional elevator is necessary. And additional elevator with a hopper configuration improve performance, but it's not sufficient. So we have to find a mixed solution with the bed lift, because the building is also is already the work is already going, and allowing a public access to only one elevator on consultation side create new unexpected waiting time. So it's not a good idea. We have to find another mixed solution. And now the best possibility is 3 public elevator in triplex, and allows employees access to the bed lift on the consultant side. And this solution smooths out the peaks over the time, give the best result regarding the employees' waiting times, the distance traveled and travel times, give the best result regarding the patient waiting times, halves the user proportion waiting more than 30 seconds, decrease waiting line size in front of the elevator bank. So it's we found something correct, so acceptable, and fulfill sanitary constraints, so there is no mixing dirty clean with the public. And so the point is, however, 2,000 people per week are waiting more than 30 seconds, but in the critical value, 70 people per week, so 14 per day, are waiting more than 2 minutes, and that's majority the employees. Yes.
So the CHUV's assessment from this simulation is to work on communication to incite employees to use the stair, particularly those who go up to 1 floor or go down to 1 floor. The addition of the new elevators is necessary but not sufficient. So the scenario number 3 has been chosen, and for the information, we obtain an agreement from the executive board to create this third elevator inside the staircase.
About the project synthesis, we can see that we had a critical situation and we demonstrated, not about the filling, but about numbers. We have identified bottlenecks. Together, we have developed scenarios to reduce waiting time. We had quantified agreement to budget the new elevator. We have proposed bank access provision strategy together with the team, and the simulation allowed to clarify the operations, how the building will work, aligned all the teams around the visual, anticipate problem by asking the right questions, and test scenario prior to the real situation without touching the system, because it's not existing, and have consolidated result thanks to the integration of variability. Yes, take a decision based on figures, not on feelings. Yes, we finished with the presentation, and just show you a very small video about the building.
Excellent. Nicolas, while that video is playing, would you be able to answer a few questions?
Yeah, sure.
So the first is, how did you model the number of patient and accompanying people taking the lift?
Dans 2 ans. Je sais pas comment refaire ça. Yeah, sure. How we quantify the flows, you say. The idea is to work with data we add from the CHUV. So we go to the direction, and the direction based on the data analysis, we characterize the flow.
Excellent.
The volume, the schedule, etc.
How deep was the controller customization of the elevators? So the question was there a call to the elevator on a given floor? Which elevator would be sent out? How did you determine that?
So here with FlexSim, we had to have a customized elevator strategy. So I can show you in the model maybe here. Here we have the process flow of the different of the elevators, and each functions are defined. And if we work on triplex like in an elevator bank, if the flow are using only one elevator, and in each flow we define which elevator to use thanks to the process flow.
Excellent. Okay, I think we have time for, I guess, one more question, and then if you wouldn't mind maybe answering a few of these other questions, you know, while the next presentation sets up. How did you model people taking steps? Did you use network nodes or did you use A*?
Network node.
Okay. Very good. And maybe one more. How long did it take to complete this model and validation?
It's about less than 1 month. Okay,
excellent. Okay, well, thank you very much, Maureen and Nicolas. That was an excellent presentation. Capacity in healthcare is always, you know, such an important issue, and I'm sure it's only grown more important during the pandemic. So it's great to hear that the 3rd elevator was approved. So congratulations on the project, and thank you so much for presenting it.
Thank you very much. Thanks for your attention.